Hi, we're going to do page 72, and this was in section 2.1. Let's do it. So we see here that generically, our arrows say that these don't really look like parallel lines. But they're close. So here's the interesting thing though. This is actually just identifying the names of what's happening here. And I want to point something out that ultimately same side interior only add up to 180 if they're parallel. And corresponding angles are only equal measurements if they're parallel. And alternate interior angles, we talked about interior, so I guess in our homework we're going to think about exterior. These will only be equal if they're parallel. But the names of their location, whether you're on alternate sides or whether you're outside, those are devoid of whether or not you're equal or not. And that's kind of a weird distinction I'll continue to make, but I do want to clear that up. So they're just saying kind of in general, what angles would be on the same side? So in class, we highlighted the transversal to help us decide location. We also used a pencil to shade in this space in between here because this helps us decide who's interior or inside. Okay, so now using this idea, they're saying what would be on the same side? So it looks like 4 and 7, angle 4 and angle 7 are both on the right of the transversal, so they're definitely on the same side and shaded. We also notice angle 2 and angle 5 are both on the left and shaded. Okay, so that meets same side, and the interior shaded meets the interior. Let me make sure you can see this. If we get this a little bit closer to the camera. Okay, so corresponding. The idea of corresponding merely means what I call, and I don't think I used the word in class, but I kind of call it a slider friend. So the two requirements of corresponding were they must be the same size on the same side of the transversal. So I don't know if you noticed it, but this angle is corresponding. It's like one's sliding into the shaded area, one's out of the shaded area. Those are corresponding. Now they don't look exactly equal, and that's because these are not parallel lines, but you still would call these two angles corresponding. They're not congruent corresponding because these are not parallel. But if we straightened out these parallel lines, these two would be corresponding, and they would be equal in measurement. Okay, so it looks like angle 1 and angle 5 are corresponding because they're on the same side and one is shaded, one's not shaded. I could also think about this angle. Angle 2 and angle 6 are both corresponding as far as location goes because they're on the same side and one's shaded, one's not shaded. 3 and 7, so you see 3 and 7, one's shaded, one's not shaded, and they're on the same side, so 3 and 7 would be technically called corresponding. And I think the last one would be 4 and 8, one's shaded, one's not shaded, and they're on that same side, 4 and 8. Okay. Alternate exterior. So this is a new word, but I'm hoping that your brain would think, oh, I think I know what exterior would mean not shaded. Okay, so if interior is shaded, this would be not shaded. So again, and back in our notes, alternate interior angles were on alternate sides of this transversal. So what would be an angle that's not shaded? So 1 and 8 are not shaded and they're on opposite sides. 1 and 8 are on opposite sides and not shaded. Okay. Who else? Looks like 3 and 6 are on opposite sides and not shaded. So those would be called alternate exterior. Now let's look at a setup where they are parallel. So I think this will make more sense based on what we did in class, but I'm still going to do the same thing. I'm going to shade this area in between here because this helps me identify the types. Okay, so which angles are supplementary? So supplementary angles, I think, were the group where they were different sizes, right? Same size means they're equal to each other. So if you remember back to the card at your table, same side means set them equal to each other and solve. Different size is add the two angles to 180. Well, that's the definition of supplementary, adding them up to 180. Okay. So, which angle would be supplementary to angle 1? Well, it looks like angle 1 is big. Okay. So, all the ones that are the same size are equal, not supplementary. So maybe using your patty paper again, you can see angle 1 and 4 look to be the same size. 5 and 8. All those look the same size. 1, 4, 5, and 8. In order for them to add up to 180, they got to be different sizes. So, angle 1 would be supplementary with any little one. So the big one plus any little one, because all the little ones are different than the big ones. Okay, so any 2 would add up to 180. So angle 1 and angle 2 should add up to 180 because 1 is big, 2 is little. 3 and 1 should add up to 180. That one's little. 6 and 7 are little. So 6 is little. 6 would add up to 180, and looks like 7 is little. So 1 is big and angle 7 is little. So those should add up to 180. Which angles are congruent to angle 1? So the congruent ones are the ones that are the same size. So angle 1 is big. I think that's this one. 1, 4, 5, and 8. We already proved that. So angle 1, angle 4, angle 5, and angle 8 are all congruent. Beautiful. How do you know? With my eyes, with my patty paper, or you could get out a protractor to be positively sure. They'd all be the same measurement. Okay, next. Find each angle. I'm gonna color my transversal, shade the area in between here. Find the angle measurement. So my choices are limited here. They're either the same size or they're different sizes. So I'm going to try to find the one that's the same. That's probably easier. So they've identified this angle 123. So angle 123. And it doesn't look like angle 2 is the same. It looks like angle 1 is the same. Okay. So angle 1, looking at my card, angle 1 and the angle that's marked 123 are the same size. So it says on my card, set them equal to each other and solve. So the measure of angle 1 has to be equal to 123. Set them equal to each other. And there's nothing to solve. It's just, that's 123, that has to be 123 because they're equal measurement. Now 2 is different. it's pretty obvious that this is big and angle 2 is little. It does not fit on top of there. So we're going to do this. Add the two angles and set them equal to 180. So this angle, 123, plus this angle, angle 2, if I add them together, they should add up to 180. So let's do that. Subtract 123 on both sides. So the measure of angle 2 is 7, 37. Let me just double check that. $50. Oh, sorry about that. Good thing I double checked it. Now let's keep going. 21 says, opposite sides of parallelograms are parallel. So that's interesting. This is a parallel line, and this is a parallel line, and this is a little symbol that just reminds me they're parallel. Opposite sides. So those are opposite sides. So I could also think of the parallelogram as going this way. They're also saying this side is parallel to this side. So this little symbol means another set of parallel lines. A second set of parallel lines are parallel to one another. Okay, so now it says, prove that the opposite angles are congruent. Okay, so they want me to prove that this angle, angle A, and the opposite angle over here would be angle C. They want me to prove this. Well, I think this is kind of interesting because there's a couple ways to do this. Check out the next video to see how.